This video begins section 4.1 of our text, where the topic is scatter diagrams and correlation. Now, we have four objectives to discuss in this section. The first objective is highlighted here in red, will be the topic in this video, is to draw and interpret scatter diagrams. And then in later videos we're going to look at the linear correlation coefficient and talk about the difference between correlation and causation. So now, our first objective is to draw and interpret scatter diagrams. Now in this chapter we're going to be looking at situations where we're describing individuals using two variables. So that's what's called bivariate data. Bivariate meaning two variables. Each individual is measured on two variables. And the natural question to ask when we're looking at two variables is whether there's any relationship between them. Now for these sections in the text, we're going to be considering the situation where our two variables are both quantitative. That is, their values are numbers, and they represent measurements or counts of some kind. So again, we're going to have bivariate data, that is two variables measured on each individual, and those variables are going to be quantitative measures of some kind, numbers. Now the example that we'll use throughout this section involves the variables age and cholesterol. So let's assume that a family doctor has selected 14 of his female patients and he gets the following data. So I've got 14 rows of data representing the 14 patients numbered 1 to 14, and on each of those patients we've got two variables measured. We've got a measurement for age and we've got a measurement total cholesterol. So again, this is what we call bivariate data because we have two variables measured for each individual. And again, the variables here are quantitative. That is, their values are numbers. So of course the doctor might be interested in how age is related to cholesterol level. It seems plausible that maybe they might be related in some way. Now the first step in examining the relationship between two quantitative variables is to create what's called a scatter diagram, or it's often called a scatter plot. And so here's a typical scatter plot. We've got the total cholesterol variable plotted against age. Now there are 14 points on this plot, one for each woman in the study. On the y-axis we have total cholesterol, and on the x-axis we have age. So each point represents the age and total cholesterol for one woman in the study. And now the natural question to ask when we look at this plot is whether or not there appears to be some relationship between the variables. And in this case, we can tentatively say, well, yes, it looks like maybe there's some relationship here. As the age of the patients increases, there seems to be a general increase in total cholesterol. Now, it's not a perfectly predictable relationship. As age increases, you notice the values for cholesterol tend to bounce around a little bit. But it's conceivable that there's other variables that might influence cholesterol level that we're not measuring here. Things such as weight, or how many grams of fat you tend to eat each day, or how many minutes you tend to exercise each day. So these are other variables that might or might not have some effect on cholesterol level. But of course here we've only got the variable age, and it does seem reasonable to say that there appears to be a relationship here. As age increases, total cholesterol tends to increase as well. Now you'll notice that I've placed total cholesterol on the y-axis and age on the x-axis. There's a reason for this. In this study we're interested in how age affects cholesterol, not the other way around. And in this kind of situation we call total cholesterol the response variable, and age is called the explanatory or the predictor variable. So the response variable is the variable whose value can be explained by the value of the explanatory or predictor variable. And in general, it's the variable you're interested in analyzing or predicting. So again, we'd say that total cholesterol is our response variable, and sometimes we'll call that the y variable, and we'll call age the explanatory or predictor, or sometimes we'll call that the x variable, because again, we're interested in understanding what's the relationship between age and cholesterol, and can I maybe predict a total cholesterol level as a function of age, not the other way around. I'm probably not interested in predicting somebody's age given that I know their cholesterol, but instead, if I know age, I might be interested in predicting total cholesterol. So that's why we call cholesterol our Y variable, or the response variable, and age is the X variable, which is sometimes called the explanatory or predictor variable. Now, this would be a good time to stop and try an exercise. Let's pull up Sullivan, problem number 25 from page 204. And if you go out and take a look at that problem, the problem is that an engineer wants to determine how the weight of a car affects gas mileage. And the following data represent the weights of various domestic cars and their gas mileages in the city for the 2008 model year. So what we've got here is we've got 11 observations, 11 cars. It's bivariate data because we've got two different measurements on each car. We've got its weight and its miles per gallon. Now this data is available to be pulled up as a Minitab data set. That's the way I've got it here, and it's also available as a StatCrunch data set. So now would be a good time to stop, try to pull this data up, create a scatter plot, and if you create the scatter plot in Minitab, it ought to look like this. So we've got miles per gallon as the Y variable, the response variable, and weight is the explanatory or predictor or X variable. And if we pull up the data in StatCrunch, create the same scatter plot, it's going to look like this. Now we have individual videos for how to use Minitab and how to use StatCrunch to create scatter plots. So you may want to stop here, check out those videos, pull up the data, and try to create these scatter plots. So now we've seen that we can create a graphic, a scatter plot for two quantitative variables, and from this scatter plot we can get a general sense of the relationship that exists, if any, between the two variables. But what we're going to want to do now is to determine some more quantitative way to describe the relationship between these variables. And that's the subject of our next video, where we'll look at the Pearson linear correlation coefficient.